So welcome back, everybody. Hope you're all having a great day. Beautiful weather today. So today we're going to talk about the factory pattern, and then we're going to talk something more specific, which is the abstract factory pattern. So I think the prof already talked about this in lecture. It is pretty straightforward. It's probably one of the most intuitive ones. So essentially, the idea is that you use this pattern, generally speaking, when you want to instantiate one of several classes that all share a common parent class. So you can imagine if you have a pizza class, and then that's like your top level class, and then you have derivatives of that class. So you have a cheese pizza, a pepperoni pizza, all sorts of pizzas, and then maybe based off some user input, you want to instantiate a particular pizza instance, but you don't know ahead of time which object that will be, because you need to determine that based off the user input. So this is where the factory pattern would come in, and just based off general programming knowledge and intuition, what you might do is you just have an if statement that checks, okay, if user input equals cheese pizza, you instantiate a cheese pizza object. If user input equals pepperoni pizza, you instantiate a pepperoni pizza object. And so the factory pattern sort of abstracts this out, and it says, well, why not just make a method that handles object creation, so you sort of get a nice separation of concerns in your code. And then you can take that a step further, and you can make a whole class that deals with that. So you have an entire class that deals with object creation, because again, you want to have that you want to follow an important principle known as the single responsibility principle. So you have a class that deals with object creation that instantiates a particular pizza instance, and it gives you a nice separation of concerns. So it's really intuitive, and we'll do a quick code demo. So you can imagine you have application, and then you have some pizza class. And then you can imagine you have a cheese pizza, which extends from pizza. And we're not going to add anything here. We'll just keep it simple. And then in application, what you might want to do is, well, you can imagine you have some string input, or let's call it user input. And maybe you can imagine if this is a website, it might be the input from a particular text field. If this is a mobile app, it can be an input from a particular drop-down menu on the actual mobile app, from a text field or something like that. So again, you can imagine that user input can come from different sources, and then it might say the user wants cheese pizza. And then again, using our general programming intuition, we could say something like, if user input equals cheese pizza, then we want to do return, or this is a void method, but you can imagine you want to just make a pizza, and then you have new cheese pizza, which extends from pizza. And then otherwise you might want to do just pizza equals just a basic pizza. And then you can imagine if you have other classes that derive from pizza, like pepperoni and so on, you can instantiate any number of those. So pretty intuitive. Now what the factory pattern says is, why not take all of this? Because this is kind of convoluted. You have this main method that has user input, and you might imagine you have all sorts of other stuff. So you don't want to throw in this object creation code that sort of distracts you. You're sort of violating the whole principle of the separation of concerns. So you want to get rid of that, and why not just make a method that does, let's do public pizza, create pizza, and why not just do that? And instead of assigning that to a variable, we'll just return it. Let's get rid of that. And we can pass the user input. And then we can call that method, right? So we could do pizza, let's just call it P, equals create pizza. And then we pass it the user input. So again, we haven't done anything crazy. What does it say? Don't worry about that. What we've done so far is we just took the code and then we put it into a method that sort of gives us a nice separation of concerns. And then you can take that a step further, and you can make a whole class called something like Pizza Factory. And the reason we refer to it as a factory is because a factory is where you produce something. And this class, this factory, produces a particular pizza instance. And so in here, we might just have a method called, actually, we'll just paste it directly. We can just do that. And then in here, we can get rid of all of that object creation code. So this entire application is now sort of, all that complexity of creating objects and all the stuff that happens behind the scenes is hidden away. And so you abstract all of that out, and then you just have your application code, and then you can call the class here. You could do new pizza factory dot create pizza. So you sort of hidden away all those low-level details, and you can imagine why that might be useful, because in this case we just have a simple, if statement check that does, user input equals cheese pizza, and then we return a cheese pizza. But this could be something more complicated, so you might do like an external database read. You might call an external API or a server, and then you might get some data, you might process it, and so on, and then determine which is the corresponding object to return. So you can imagine it might get really complicated. So if you put it into another class, that hides away all of that complexity, and it gives you a nice separation of concerns. And it also follows an important principle known as the single responsibility principle, which is that a class should only have, you should try to aim for your classes to have a single purpose. And this class serves exactly that purpose, that it creates our objects. Any questions so far? It's intuitive? Yeah. Good. So let's move on a bit. So the factory pattern is really easy, really intuitive. Now let's talk about something known as stable abstractions. So what we've done so far is we have this app that we just looked at that had our main method, and then we created a pizza factory. So we have this sort of dependency between app and pizza factory. Now, what would happen if I changed that create pizza method and I name it something different? Let's say, create user pizza, or I just change it for whatever reason. What would happen to app, our main program? And again, maybe I can bring up the code. So this is our pizza factory. So imagine if I change this to another name for whatever reason, what's going to happen to application? So what's going to happen in this main method? Anyone know? It's not a trick question. Yeah, you're going to have to change this, right? And then you can imagine if I change the parameters here, you also have to change this here. And then if I rename the whole class, I have to change that. So you can sort of see what's happening. And the problem is that essentially we've created this dependency between our application and, give this a second, we've created this dependency between our application and pizza factory, which is generally we should avoid that. So this is where a principle comes in known as the Dependency Inversion Principle. So the idea is really simple, and the idea is that you've started to depend on something which has made your application volatile, because your pizza factory is, it's subject to change. It's going to change the name. It's going to add methods, remove methods. It's not something that's stable. So what we want to do, we want at least our application to be stable, because that pizza factory is dealing with all that object creation stuff. We don't want any changes to that to sort of directly break application, right? So we want to make application as stable as possible. So the way we deal with that is instead of depending directly on pizza factory, the idea is you want to depend on what's known as stable abstractions, and we'll talk about that in a second. But the way you achieve that is by depending on abstract classes, or usually interfaces, instead of concrete classes. So a concrete class is something that has implementation specifics, right? So the pizza factory, it had implementation specifics because it depends on that cheese pizza class, the pepperoni pizza class, and so on. It has a bunch of specific implementation details that correspond to object creation. That's something that's referred to as being concrete. That's not abstract. And we don't want a dependency on that, because that's something, implementation details are always subject to change. And this is, again, motivated by the dependency inversion principle, where you don't want this dependency. Instead, you want to invert that dependency. And we'll look at that in a second. So this is where the abstract factory pattern comes in. So you can imagine what we had so far was app and pizza factory. So at the top there. Now let's grab that. So instead of having this pizza factory that does the object creation, let's first make two interfaces. So one of these interfaces is the pizza class, which I labeled as iPizza, just so it's clear that it's an interface. And this is also an interface. So we have two interfaces, but notice that our application only depends on these two interfaces. So our application never depends on pepperoni pizza or cheese pizza or particular classes that extend from this interface. Our application never depends on that. Our application only depends on interfaces. And when we get to the code, you'll see why this is important. And this is important because, well, it'll be more obvious when we see the code. But again, we don't depend directly on cheese pizza. So if you change the name of cheese pizza, that's not going to break out. If you change the class of this name or whatever method in here, or you know, anything related, and if anything changes in this class, your app is not going to break directly. So what we have is we've made a pizza class, which we sort of had already, and then we have derivatives of that. So this is an interface. These are implementations. So this in Java, this would be like cheese pizza implements iPizza. And then you have this iPizza factory. So instead of having that previous method that was just called pizza factory, we have an iPizza factory, which is an interface. And then we have concrete implementations of that factory. So you can have different factory methods or classes rather. So you can imagine what we did is over there was check user input. But you might want to check some other condition and then instantiate a pizza object. So you can make another class for that rather than bundle all of that together. Any questions about this so far? So we'll look at the code. This was really confusing for me when I learned this because it was just not obvious what the relationship is. So it'll be more obvious with the code. No questions so far? All right, good. So let's look at that, and we'll follow this. This always takes a second. We'll follow this as much as we or like we'll keep referring to this because it gives you a good mental model of how to structure your classes. So let's go in here. Just a sec. Okay. So first of all, let's change this to an interface, public interface, and let's call this iPizza. And then the other thing we had was a pizza factory interface. So let's do iPizza factory.java. And let's get rid of all, let me just delete this actually. I'll copy this and then let's get rid of this class. So we have the iPizza, we have the iPizza factory, and then we have cheese pizza, which implements pizza. And then you can have all sorts, as many pizzas as you want essentially. Again, this is also going to implement our iPizza. Okay, so we have cheese pizza, and this should be iPizza. So we have cheese pizza, we have pepperoni pizza, pizza factory, iPizza, and then we have our application. Now, what we're going to do is basically in our iPizza factory. Oh, there's one other thing. So we have this iPizza interface. Now we need a concrete implementation of this interface. So let's change that. And then because this is an interface, we can specify methods without the body. So let's do public pizza, create pizza. And you can't provide an implementation for this because this is an interface. So this is as abstract as you can get. So again, let's refer to that diagram. So what we did so far is we changed our pizza class to iPizza, pizza factory to iPizza factory. We created a cheese pizza class, pepperoni, and now let's do this one, which is our implementation of the iPizza interface. So let's do, let's just call it pizza factory. Let's call it pizza generator. So this is just going to implement, this implements iPizza factory. And then now we have to actually provide an implementation for that method. So we have, it was public pizza, create pizza, and I'm just gonna, actually, let me just paste that directly. So I had this code from earlier, which I'm just gonna paste. Let's see, this is iPizza. Return new, this should be, let's do pepperoni. So, create pizza. Oh, so let's go here. Let's add that argument in there. Okay, close everything. So what we've done now is we took that pizza factory that we had, we made an interface that specifies just a generic create pizza method. And then inside our implementation, we basically actually, or inside, we create a new class So the IMPL just is short for implementation. We just call it pizza generator in our case. That just implements this class, and then it actually provides an implementation for that method, which is based off the user input. And then you can imagine if you want to instantiate these pizza objects based on some other condition, you can make another class that also implements iPizzaFactory and then handle all of that stuff in there. So now if we go back to application, what's going to happen is we're going to create. So the way now we're going to create this object is, does anyone know? So now our application, so maybe the UML diagram will help. Our application only depends on these two interfaces. So now if we want a cheese pizza, how is that going to work? Any ideas? Yeah. Yeah, yeah, that's right. And does the create pizza take any arguments? Yeah. So how are we going to instantiate the iPizzaFactory implementation? Whatever. Call it pizza generator equals new iPizzaFactory. No, not iPizza. This would just be pizza generator. What would be the type though on this over here? Would it also be pizza generator or? So do you remember what pizza generator is an instance of, or which interface it implements? Yeah. So what we would have is basically you want a dependency between application and the interface rather than this directly. So instead of doing this, which is not what our UML diagram says, what we just did creates a dependency between app and this. That's not good because again, we don't want to depend on concrete things. We want to depend on abstract things. Because again, you can imagine if that changes, you're going to have changes to app, but also if you have many different types of implementations, you don't want your app to depend on all of those. So you want to depend on this interface directly. So that's just a little thing to keep in mind. It's easy to sort of forget that. So you want to do that. Instead, you would do iPizzaFactory. And the reason that's valid is because that's a child class of that implements that interface. And then now what we can do is PizzaFactory, or not PizzaFactory, pizza generator dot create pizza, and then we pass the user input. And that's basically how you would get a particular pizza. And then we can assign that. And again, you wouldn't do something like cheese pizza equals that, although that's, what does this say? Yeah, so this isn't even valid. And the reason you wouldn't want to do this is, again, you want a dependency between app and the interface, the top level abstraction, rather than the concrete implementation, which is cheese pizza, pepperoni pizza, and so on. So let's fix that. So instead of that, we're going to do iPizza. So now notice that the only thing our application depends on is iPizzaFactory and iPizza, which is exactly what our UML had. So now if I go into, like pizza generator and I make a bunch of changes here, none of that is going to affect any of the code here, as long as I respect the contract between application and pizza generator, which is this method. As long as I don't change this name and I respect that contract and I don't change the arguments here, doesn't matter what I do in here, application will never break, right? So again, your goal is to make your top level, or your goal is to make this application as stable as possible. So we've made it more stable by making it depend on abstractions or interfaces, to be more specific. And we've made those interfaces have these well-defined, have a well-defined contract that we're going to respect as much as possible. So we're going to respect this name. We're going to respect the method, like the name of the class. We're going to respect the name of the methods, the arguments. So we don't want that to change because we don't want it to be volatile. Okay, any questions? So this is what's referred to as the abstract factory pattern. Now this is slightly different than the factory pattern. What we talked about earlier, where we just made a method, that's not exactly a pattern. It's basically a method, and then we just took that idea and applied it to a class. This is something like that is a little bit different. It builds on the same idea, but it introduces this other principle known as the dependency inversion principle. And again, the idea is you don't want to depend on concrete things and implementations because those are subject to change, and that makes your application volatile. So instead, we depend on stable abstractions where we try and respect the contract of those interfaces as much as possible, so that your application is as as less error prone as possible. Any questions? Everybody's good? So this was really confusing for me the first time. So if you guys get it, that's great. All right, looks good. So let's do one other example. We're going to use this example of a storage service, very similar, almost identical UML diagram. But what we have is we have an application, and then we have this, top level abstraction, this interface storage service, and then you have concrete implementations of that. So you have a cache storage, you have a hard disk storage, and you can have like an external database and so on. You can add as many as you like. And then what we're going to have is our application wants to read something from the storage, but we don't know exactly which storage it wants to read from. So it could read from the cache, it could read from the hard disk, it could read from an external database. We don't really know because it depends on how busy our system is. So you can imagine if this is like a website. If the website is, there's not a lot of active users, it's fine to go ahead and go to your sort of hard disk, which is more expensive to read from than your cache. But if your website's really busy, then you might want to read from your cache. You want to serve those requests to users as quickly as possible. So that's like a little more practical example. And then so what we might want to do is, instead of our application does some like convoluted logic and then it calls cache storage, and then we abstract all of that out and we say we have the storage service, and then these are just some example methods it might have, like a get user, and then if this is like Instagram or something, you might have the get posts based off like a user ID, and then what we want to do is you want to be able to sort of, your application wants to be able to figure out which storage service to call. So you have, again, a factory for that, which has a create storage service, which returns an instance of iStorage service, which could be any of those, cache, HDD, hard disk, whatever. And then you have a storage service generator. There's a little typo here. So you have a storage service generator that implements that, and then it returns a corresponding storage service. So let's go ahead and do the code for this. So it's very similar to what we've done already. Give this a sec. Okay. Any question about this code? Otherwise, I'm just going to delete it. Or let's make another method. So again, looking at the UML diagram, let's make a top level app. So this is where we're going to have our sort of our main method and stuff, and sort of our main application. And then we had the storage service interface. So let's do iStorage service. And this had two methods. Anybody remember those? And this is an interface. Do you remember the two methods? So yeah, get users and get posts. So we have public string get user, and then we have an int ID. And again, this is an interface. So just specify the method signature. And then you might have string get posts, or maybe it's like an array of strings, whatever. And we pass it like a user ID to that. So we have the storage interface. And then we're going to have the storage factory. And first of all, we're going to have like a generic storage service factory, and then we're going to implement that. So iStorage factory. Let's do storage service factory. And this is basically going to do public create storage service. Anyone know what the return type of this method is? Anybody want to guess? Sorry? Yeah, or iStorage service, right? So again, the interface. So if we had like a, now we're going to implement like the cache class and so on, but you wouldn't make that the return type again because you want to depend on those abstractions. So this would be iStorage service, and it's just complaining because we didn't specify it's an interface. Okay, so that's our top level class. Now again, so let's take a look at the UML diagram. What we've done is we made the storage service with those methods. We made the storage service factory. So let's go ahead and now do the storage service generator. You have storage service generator. So this is going to, this implements iStorage service factory. So not the iStorage service, because this is like the generator. And then we'll implement this in a second. And then we had the cache and then the hard disk drive class. Let's do let's do cache storage. Let's just call it cache, just so we have to type less. And then we have, and then in here we can just do something simple. So first of all, this is going to implement the iStorage service. And then we had the public string. It was get user based off the ID. So we can just return like, found user in HDD with ID, just something simple. And the other class was get posts based off some ID. Let's just do something simple. We'll do string posts, post 1, post 2, and so on. And again, you can imagine you can have all sorts of different logic in here. Like you might actually get the posts from like some database or something. And then you can just return this. And let me fix that. Should be good, yeah. And then we have the cache. I'm just going to copy this for the cache class. Let's change that. And we'll change this to found user in cache. Get posts. We'll just keep it the same. Let me close all of that. So let's look at the classes we have so far. We have we have our app, which is gonna basically, it's like our main program. We have our iStorage service, which is our top level, our storage. It's like the top level thing, our interface. And we have our iStorage service factory, which is our generic factory class. And then we have a concrete implementation of that factory class that implements iStorage service factory. And actually, let's add that method in. So it was public iStorage service, and this was create storage service. And here, what we want to do is we either want to return an instance of the cache class or an instance of the hard disk drive. So you can imagine, I gave the example earlier of, depending on how many active users there are on your web application, you might want to, go with your cache or your hard disk drive. So let's just make a method called get active users. So this will just return how many people are currently active on your website. Don't worry about how it actually works. We'll just do something simple. We'll return like a random number. So we'll do and then we'll just do next int between like 0 and 200 or something. So you'll have like 200 users at most. Let's import that. So this is just for the sake of example. And then let's make one other method that tells us whether or not, the system is too busy. So let's say if there's more than 100 users, the system is considered busy. How would that translate to our code? So it's not a trick question. It's pretty straightforward.
So if get active users is greater than 100, did you say 100?
Yeah. We would just do return get active users greater than 100. And, this should be Boolean. And then in here, essentially, anyone know what's going to happen in here now? Our create storage service. So again, we want to return an instance of cache or HDD based off of whether or not the system is busy or not.
It's busy, return a cache instance, otherwise return an HTTP.
Yeah, perfect. So if it's busy, we probably want to go to our cache, make it quick. So we'll do return new cache. Otherwise, just return new HDD. And you can imagine you have like 10 different classes, 10 different types of storage services, and you can have a condition for all of them and add whatever logic you want, as long as all of that is encapsulated in this particular storage service factory implementation. So now let's go to, so we have our cache, we have our HDD, we have our storage service, yeah. And we have our top level interface for the factory, and then we have a concrete implementation. So again, looking at that UML diagram, we've done everything. So we've done this, we've made this, and then we just have to figure out our app. And notice that this has a creates relationship. So this is essentially, creating an instance of that, which we just saw with return new HDD, return new cache, and so on. So let's go to app, and let's add a main method. So anyone know how we're gonna go ahead and use this? Any ideas? So it's very similar to the last example of the pizza. You have a question? I thought.
Can you look at the UML diagram?
Oh yeah, sure. Yeah, that's always helpful. So let's say you have a user ID already, and then you want to get, that user from in your app. So over here in your app. So how are we going to do that? So again, it's similar to the pizza example. Nobody?
You're creating a new iStorage service factory, and then I believe you're crossing that to iStorage service after that.
iStorage service factory, and then passing it to.
Not passing it, but like.
Yeah, you're going to call the create storage service. Yeah. So let's do that. So we have iStorage service factory, and let's just call it factory, so we have to type less. And that's going to be new. Anyone know which class we're going to instantiate here? So just so you can see the class names over here. So is it going to be iStorage service factory? It's a generator, yeah. So first of all, you can instantiate an interface, and even if that was an interface, let's say it was a class, you want a dependency between app and the top level class rather than the concrete implementation. So again, just keep that in mind. So this equals new storage service generator, and then what we can do now is factory dot create storage service, and that's going to return either the cache or HDD. And so we can assign that to, let's assign it to storage service. Anyone know what the type of this is going to be? Sorry?
The iStorage.
Yeah. So again, I just want to keep reiterating this. This would not be like cache, okay, or HDD. This would be iStorage service because again, you have a dependency between that top level abstraction rather than the concrete classes. So this would be iStorage service, and then now it's really easy. Let's say you just have a user ID 1, 2, 3, 4, 5. You can just do, so let's do this. Storage service dot get user, and then you can pass the ID. This is really clean because I can go ahead in my storage service generator, and I can add like all sorts of crazy code that figures out whether you should go to your cache or your hard disk drive. You can do like anything you want in here, and that's not going to change app at all, as long as you respect sort of this this contract essentially. As long as that method doesn't change, like the name or the parameters or something, as long as that's respected, this app doesn't even need to know about anything that's happening in the generator, because all of that has been sort of separated, and you have a nice separation of concern. So that's really the essence of this, this pattern, but also this more general idea of dependency inversion. And you'll see, the prof might talk about this later on, but I think it's a more general idea. I think it's called a dependency rule or dependency pattern or something, which is really that you don't want to depend on concrete things because they change. So if I depended directly on this, changing my app could potentially break. Changing things in here, if my app depended directly on this and I change things in here, there's a possibility it'll break. But because I depend on concrete or I depend on abstractions and interfaces rather than concrete classes, I minimize sort of the chance that this thing could potentially break. So if you go ahead and run this. Any questions, by the way? So let's do. So it says found user in hard disk drive with this ID, but I can run that again, and now it'll be cached because again it's a random number that determines what which class is being instantiated. So yeah, you can keep going with that. Sometimes it's hard disk drive, sometimes it's cache. Again, it's random, and then you can add all sorts of different classes in there. So any questions? Yeah.
Inside your generator, what might you did some things as public and you assign others as private?
So the idea is that this is a concrete implementation of iStorage Service Factory, and it's going to have a number of implementation specifics. And the reason we do that as private is because it's sort of specific to this particular generator, right? So you might have another generator that checks other things, and all those implementation details are abstracted or they're buried inside of that class. So this is the idea. We don't need this publicly. We don't need that either because it's sort of buried inside of this class. Okay. Other questions? So yeah, it's a very, very cool pattern. Once you sort of understand it, you really see the essence of it, which is that don't depend on concrete things because they change, they're volatile, depend on interfaces and abstractions. And it's again, patterns are always a rule of thumb. This isn't something that you're always going to have to follow. In fact, it might even be a bad idea in some cases. So always take these with a grain of salt and use your judgment as to whether or not it's worth the effort to actually follow a particular pattern and whether or not it's actually appropriate to that particular problem. So again, this is a rule of thumb. It's not like a hard and fast rule. And that's all. So if you have any questions, I'll stick around. Otherwise, I'll see you guys next week.